So today is day 4 of your STAAR review, and today you're going to have 2 separate videos, and this video is going to be talking about the real number system. So going to your foldable here, or to your folder, you should have already pasted your the real number system foldable right here. So I'm going to go back to the review, and again we're talking about the real number system first. So this will be the first part we're going to talk about. So back to your foldable, you're going to open your foldable up, and this is where you'll be writing all of this information. So here it says label the diagram below: integers, irrational, natural, rational, real, and whole. So this is called the real number system. So all of the numbers here belong to the real number system. So the outermost layer is the real number system. And we're going to go ahead and start off at the very inner circle in this big circle. So this is called, these are your natural numbers. So these are your counting numbers. So whenever we naturally start counting, we go 1, 2, 3, 4, and so on and so forth. And then you go into your whole numbers. So your whole numbers include all of your natural numbers plus 0. So 0, 1, 2, 3, 4, so on and so forth. And then you go out again, and now you have your integers. Now your integers include all of your whole numbers plus your negative numbers. So this will be -3, -2, -1, 0, 1, 2, 3, so on and so forth. Then all of these numbers are in the rational numbers, are rational numbers. So rational numbers are anything that can be written as a fraction or that have a decimal. So for instance, these can be numbers like 1.5. You can also have a number like -2.5. You can have a 0.3, and this means that it's a repeating, a 0.3 with the bar on top. That means it's repeating. You can have -4. You can have 1/4. And then 0 is also considered a rational number again. So these numbers are rational numbers. Then in this other separate circle, so rational numbers and irrational numbers are completely different, we have irrational numbers. So irrational numbers are numbers like pi, and then for instance the square root of 2. And I want to show you, whenever you go into your calculator and you put the square root of 2 in, you get a really ugly number, and it goes on forever and ever, and it's a non-terminating decimal. So it's just going to be going on forever and ever. And then you have negative square root of 3. If you get a number like 4.2467769 that has no pattern to it, that's also irrational. So rational numbers here, these have, you can either have a repeating decimal, or you can have a terminating decimal, or it can be a fraction. So repeating, terminating, decimal, or a fraction. So really quickly, looking at our foldable now. So this is everything you should have written down at this point. But we're going to go ahead and get a closer look at number 1. So we're going to be here. So number 1 says, which point on the number line is closest to the approximate value of the square root of 75? So before I can determine where it lies on the number line, I have to put this in my calculator and see what it equals. So going to my calculator, I'm going to put the square root of 75. And this is what I get, 8.66025. Now, I want you to think about, where does that lie in the real number system? It has a non-terminating decimal. This goes on forever and ever, and there's no pattern here. So this is going to be an irrational number. So square root of 75 is equivalent to 8.66. So I know this has to be between 8 and 9, so I know it can't be L, and I know it can't be P. So point L, point P. So looking here in between M and N, so I know this is 8.2, 8.4, 8.6, and 8.8. So since this is slightly to the right of 0.6, the point closest is going to be point N, which means H is my answer. Okay, so going and looking at your foldable, this is what you should have written down for example number 1. So now I'm going to go ahead and close my flaps, and we're going to now be looking at number 2. So this is where we're at now. So for number 2, it says, on which number line does point P represent the approximate value of pi times the square root of 5? So going to our calculator, we're going to type in pi times the square root of 5. We get 7.02. So pi times the square root of 5 is 7.02. So I know that my number should be slightly to the right of 7. So P is in between 5 and 6, so that's incorrect. So F is not my answer. My answer should be right here. G, my answer should be right here. And P is way closer to 8 than it is to 7. So that's incorrect. Again, my answer should be right here at 7.02, and P is less than 7, so it has to be above 7. And then J is in the correct space. It's slightly to the left of 7, so that means J is my answer. This is where point P belongs. Okay, so on your foldable, this is what you should have written down. Pause if you need a second, but next we're going to go ahead and we're going to look at number 3 now. So number 3 says, which diagram best represents the relationship among rational numbers, irrational numbers, and real numbers? So remember that this is called the real number system. So when I draw my box here, both rational and irrational numbers belong to the real number system. So this should be on the outside of all of your boxes. So that means you can automatically eliminate B, and then you're left with the others. Now, going back to the first, whenever we sorted out the each of the number types, here you see that your rational numbers and your irrational numbers are two separate types of numbers. They are not the same. They are two separate categories. So I should have rational numbers on one side and irrational numbers on the other. So again, A and C, I have irrational numbers as rational numbers, and that's not correct. They are two separate types of numbers. So that leaves me with D. So this is the real number system, and I have rational numbers and irrational numbers. So looking at your foldable, this is everything you should have written down for number 3. So if you need a second, go ahead and pause. But other than that, we're going to go ahead and get into the last example, which is number 4. So we're right here on your foldable. So for number 4, it says Nikita drew the Venn diagram below to classify 10 different numbers. The shaded part of the diagram best represents what? So I know these are at least rational numbers, so looking at my answer choices here, I can eliminate irrational numbers. I don't see anything like pi or anything that's taking the square root of something. Going to my outer shell. My outer shell, I have fractions and decimals. So integers are a subset of rational numbers. So I know that this shell is rational. And I know that I have negative numbers, I have 0, and then I have positive numbers. So I know that these are integers and rational numbers. So looking here, I should have integers and rational numbers in my sentence statement. So G has whole numbers as a subset of rational numbers. These negative numbers are not whole numbers, so you can eliminate G. And again, we're in between F and H. So here it says integers as a subset of rational numbers. So this says integers inside rational numbers. So here I have integers inside of the rational number shell. That looks correct. Then we have H, rational numbers as a subset of integers. So remember, subset means inside. So my rational numbers are on the outside. So H is incorrect. And here F is going to be your answer. Okay, so lastly, looking at your foldable, this is everything you should have written down for number 4. So that was discussing the real number system. So now you can go ahead, and if you've watched the video going over interest. You've now watched the video going over the real number system. You can now go ahead and complete your assignment for the day.